welcome to this proof of concept. So I've been working on this project for a while and I would love to share how it works. So this project is a RAG-powered um, LLM project that uses Gemini 2.5 Pro model to perform CloudTrail analysis. So it's basically a cloud analyzer. Okay, CloudTrail analyzer. It analyzes CloudTrail events, and there are two types. We have the deep event analyzer and the sequence event analyzer. Um, these particular analyzers are powered by RAG, an external knowledge database. So within the knowledge database, we have cloud MITRE cloud metrics framework crawled. We have the security blogs, that's latest security blogs. We have threats, Intel's threat report, latest threat reports. We have AWS threat technique catalog, which was recently released, and kind of more a lot of resources. And these are all stored within Google storage. Um, Google storage. So and they're also chunked. All right, I'm going to show how it's done, how I integrated an interface to chunk that. But basically, the entire um, project is to improve post-incident CloudTrail analysis and also to leverage RAG, which basically helps the LLM where it's limited in most recent information or knowledge base. So with the help of this external knowledge base, right, which is stored within a RAG database, right? So what happens here is that the embedding model, which is the multilingual embedding model 002 model, basically chunks this data and embeds them within a vector database. So when the CloudTrail event is being uploaded, right? LLM, the first thing Gemini does is to convert it into an highly quality natural language search queries. So what this means is that it's going to pick an event and put it to a more understandable, human understandable language. So more like user James performed a console login from this particular IP at this particular time. And now this natural language query are passed into the second Gemini Pro API call to call or to query the vector database. So this particular query also is also converted into a into vectors, which basically search the database for similar knowledge or context to be able to analyze this data. All right. All right. So let's walk through the crawling for a start. So let's see we have a new article that was released and we want to add that to our database. All right, our RAG database. We crawl the content of it and upload it to our RAG database, which get uploaded to our Google storage cloud or our Google Cloud storage, basically. Then, if you have, in cases where we have things like threat reports, all right, and we want to upload threat reports, we can upload some threat report. We can upload some threat report. Like for example, this is a threat report, Google Cloud Threat Detection Report. We can upload that, crawl that rather, and upload the content. So this helps our LLM when performing analysis to get more resources rather than just depending on their pre-trained data. So here we're doing a deep event analyzer. I've uploaded a CloudTrail JSON log, which basically, so in this particular JSON, this particular file, we have how many events? 1, 2, 3, 4, 5, and 6. So we basically have 6 events. Yeah, we have 6 events within this particular file. So for each event within this JSON file, it basically gives us a deep analysis. So a successful login console was recorded by James at this particular time, highly suspicious. It gives us the suspicious assessment, why it thinks it's suspicious, and also gives us a MITRE attack mapping. Also gives us the AWS threats catalog. All right, gives us justification for that. So in cases where we have our guard duty already detected this and we want more investigation, we can export the log, and which is what this particular product is for. You export the logs and upload it here, which basically gives you more analysis. All right, more context or analysis. So James, the ARN, the Amazon resource name, the account ID used, then what enabled this attack or this what enabled this this severity score justification. Now to the threat reactive threat modeling part, which basically gives us a reactive threat modeling of using Stride to give us more clarity on our understanding, and this basically helps us to improve our proactive threat modeling. So a reactive threat modeling improves our proactive threat modeling when we are trying to improve our proactive threat modeling, and also to um, enhance our incident response plan. So how do we respond to incidents when we have users who are being compromised and stuff like that? So the second event is the create access key. So it gives us why this particular event happened. Okay, why did this particular event happen? That's the question. And now it's giving us context to, oh, this is the mapping, justification for it, the affected assets regarding this event, justification, also a reactive threat modeling. So the observe key is a strong indicator of persistence of an attack. All right, to ensure the maintain photo. So this is what an attacker would literally do if they have, if this event was actually performed by the attacker, right? Then we have attach user policy. So an anonymous API call was made by James to perform attach user policy action, all right, which is highly irregular, all right, so it's highly suspicious. And then we have MITRE attack mapping justification for it, and we have also the containment severity score and the likes. Same thing for, so for each event it gives you the severity score. So this is basically just helping you understand, giving you more context to each event. So like for example, list bucket. So this, for list bucket, now this event happened, James performed a list bucket. A list bucket could be a benign event or it could be a malicious event. But in the case where you suspect an event or you suspect an attack or an incident, right? That's where this tool comes in. You extract that particular timeline where that event happened, upload it, and then get an event analysis to that event. Okay. So for list bucket, it gives you why it's actually a reactive, why it gives you that why an attacker, or what an attacker would have done, or the possibility of that. Then we have reactive threat modeling, assessments for events. So the part where the last event, which is the delete trail, basically the attacker was able to delete um, CloudTrail, um, and also gives you the MITRE attack mapping and the threat detection, the AWS catalog threat technique mapping as well, the guard duty detection, affected asset potential remediation, and recommended actions as well. All right. So beyond just this analysis, right? Beyond the deep event analysis, we have the sequence analyzer. So it gives you a sequence of what happens. So within AWS console, James performed this action with the AWS console. Initial access, all right. So these are key indicators. Gives you a summary visualization of what you just saw earlier. From the source IP discovery, collection to deleting the event. All right. So that's basically it for deep event analyzer. So for sequence event analyzer, so let's try to upload for. All right. So for the sequence event analyzer, we can also look into that part next. For the sequence event analyzer, which compared to the deep event analyzer, for the sequence event analyzer, it basically combines all the events. All right. So instead of doing a deep event analysis, so picking each event like the console login, the create access key event, the attach policy event, instead of doing all of that, the sequence event analyzer combines everything together to give you um, a full understanding. So here it says an entity, I am user James logged in, created an I am access key, and immediately attached a policy to their user. This was followed by S3 enumeration by listing buckets, data access objects, and attempt to cover their tracks by deleting trail. So this is highly suspicious, um, potentially malicious. It's suspicious and it's malicious, potentially malicious. And this is where the sequence of action taking the technique ID, MITRE ATT&CK technique ID mapped was this: create, modify um, cloud accounts, cloud infrastructure discovery, data from cloud storage, impaired differences, and also giving a justification for that. All right. Then we have the AWS threat technique catalog as well, which basically gives us different technique catalog, which is their own um, new what's it called now? New catalog for mapping events within AWS. Then we have justification as well. We have relevant guard duty findings as well, which are all this. Then we have the affected assets, which are all this. Set notes: log inconsistency shows this key used for login before its creation, suggesting a compromised initial key was used. All right, so it see how detailed it gives you that. All right, then the cloud a tree was deleted, impairing security visibility, and also potential misconfiguration. The user James likely possessed permissions like these permissions that allowed self escalation, so they were able to violating the principle of least privilege, and also the issue of no service control policy or permission boundary, which prevents in place, which would have actually prevented James from modifying their own permission or deleting CloudTrail. So the severity is actually very critical, and these are the immediate recommendation to get this. So immediately disabling I am user James, and also re-enabling CloudTrail logs, and investigating what objects or storage objects within the S3 were affected. So for the reactive threat modeling, right, it gives us the breakdown, the sequence breakdown. All right, attacker gain access credentials for James, the persistence and privilege escalation, discovery and collection, and defense evasions. All right, so it gives that sequence. And also you could see here we have the spoofing, tampering, information disclosure, escalation of privilege. So it gives us that in respect to stride. And also it uses the risk metrics. All right, the risk metrics, which is used to grade the likelihood. So we have likelihood very high due to direct ambiguous evidence of CloudTrail logs, right? And the impact is 5/5. So this is a very critical so the sequence same logs were fed into deep analyzer and sequence analyzer, but the deep analyzer gives you detailed analysis for each event. Sequence analyzer combines everything together and gives you a sequence analysis. All right, then for the attack sequence for the sequence analyzer, all right, we have James performing AWS console. Then we have persistence. So I am service, within I am service, by creating a new key, James was actually, the attacker was using James to create a persistence within the environment. We have attach policy, also escalating privileges. Discovery, so they use the list bucket to discover object within S3, then get object for collection and exfiltration, and then we have deleting CloudTrail for defense invasion. So yeah, this is pretty much the summary of the entire project. Just to reiterate from the architecture that API Gemini Pro was used as the powerhouse or the LLM for this analysis. However, an external RAG database was used, which are basically converted to a vector database to be able to find more information. So Gemini might be limited in its pre-training data sets on some knowledge, on cybersecurity knowledge and context. So in cases where you as a security engineer, you get the latest blog or the latest information and you want to upload to the RAG database, right? You get to crawl, upload it, either blog or threat info or PDF. You get to crawl it, upload it to a RAG database, and from there it's going to Gemini is going to pick it up and analyze it for you for more context. All right, that's pretty much it. I'm going to do another video to show the back end of how the entire thing works. All right, thank you.